We are finally going to do things that you learned in grade 11. Right. So what was new in grade 11 is we're now going to look at limiting agents. Now, for the first time, we're giving you things that are not going to react in the right ratio, because some of that will be too much, and if you have something that is too much, some of that will be left over on the table, right? So if you look back, just quickly turn to where we did this on page, this question 20, on page 29. We said calculate the volume that is needed to produce. We assumed that there's enough of the other substance, right? Or they said to react completely. It meant we didn't have to think about the other substance. There was enough for us to react. But now for the first time, they're going to give you two things and you don't know if they're going to react completely. So let's look at the example. They tell you sodium burns in oxygen according to the following balanced equation. Nice of them to balance it, right? And now they say 483 grams of sodium is placed in a container with 129,92 cubic decimeters. So you have a mass of the sodium, you have the volume of the oxygen. Now we used to have only one, and there you step 1, step 1, 2, step 3. Now they give you 2. So what comes in now is once you've calculated the mole, you have to do something new. You have to make a decision. With which one are you going to go on? Now, should I use the limiting agent or should I use the one that is in excess? The limiting agent, right? The one that is fully used up. Because all of it will be used to produce product. If I use the one that is in excess, I will get too big an answer. Because some of it will be used and some of it is actually not producing product. It's lying there on the table, right? So you have to work with the limiting agent. So the first thing is always to go to moles. So if we had that, we said, okay, go to moles, go to moles. Now with that, you're very good now. So let's not even talk about that. But now I have to decide which is the limiting agent. And for that, we have a decision step. Right. Now for the decision step, I say, okay, we know they're not going to be reacting with each other. I know what's available and I know what's available. So let's close one of this and see if all of the other one react, how much of this is needed. So I know there's 5,8 moles of oxygen, but just forget about oxygen first. And say, okay, let all the sodium react. So for all the sodium to react, how much oxygen will be needed? So I say, okay, sodium to oxygen, they're in ratio 4:1. So I've got 21 of these. How many of those? Cross calculation, 5,25 required. Okay, and then I again open up and see, okay, 5,25 required, but I have 5,8. What does that mean? I've got more than enough. Some will be left over. Right. So the O2 is in excess, and immediately sodium is my limiting agent, and I say, don't do anything more with oxygen because it is in excess. If something is in excess, I'm going to ignore it for the rest of the question. Right. And then the rest of the question goes easy, because now they ask us, determine the mass of sodium oxide. Now we can continue with that one because we know it's the limiting agent. Everyone happy? So we're going on, and then we get to something like question C. Question C is the more difficult one, and that is calculate the mass that remain. Now when they ask us what remains, sometimes we can already use our decision step, and sometimes we have to redo it the other way around. So for this instance, we know sodium is in excess. We know we started off with 5,8. So what we need to know is how much of that 5,8 is going to react. And we've already worked that out. That is how much is going to react. So we're just going to subtract it to get how much is left over. Right. But sometimes we have to do that decision step the other way around. So let's do 2 to see if you are comfortable with it. If you have problems, refer back to the example, right? So on the next page, number 1, I know the space is very limited, so if you want to work in there, you have to write very small. Huh? Otherwise, use a separate paper. So do number 1 on page 33. Right, did you find H2 as your limiting agent? Yes. So that means from here on, I'm not going to work with N2 because N2 is in excess. I'm just going to ignore it. Right, so this was the first part of the question. You worked out the moles and you use it to get the limiting agent. Second one, what volume of ammonia? So for ammonia now, I'm looking for the volume. I'm going to work with the limiting agent. So I'm going to work with H2 to NH3. They're in the ratio 3 to 2. So if I have 10 reacting, how much will be produced? 6,67 moles of NH3. But they don't want it in moles, they want it in volume. So just quickly translate to volume. Okay, everyone, they're asking about rounding off. If you round off, you can keep everything in your calculator. You don't have to round off, right? But you can also round off to not less than 2 after the comma, right? And eventually the Department of Education will mark both. They have a range. It is between the rounded off answers and someone who haven't rounded off and used everything in their calculator. So both are fine. Right. So if your answer is a little bit different, that's fine. It depends on how you round it off. Right. The most difficult part is actually number C, I think, where you have to say what mass of the reactant in excess will remain. Now, which one was in excess? N2. And I know for N2 that I started with 3,57. So what I now need to know is how much reacted. Now sometimes your decision step will help you, this time it does not. So this time I'm going to do this, but the other way around. I can say N2 to H2 is in the ratio 1 to 3, and I'm now going to say, I know all the hydrogen is going to react. So how much of the nitrogen will react? And that will give you 3,33 moles of N2 will react. And then you can say, okay, so how much of the N2 will remain? And that should be the 3.57 that you started with minus the 3.33 that reacted, and that means you end up with a 0,24 moles. Are we finished yet? Whew, not, and the space is getting all smaller and smaller. Eh? But fortunately, very easy. Eh? Moles is mass divided by molar mass. Moles being 0.24. We're looking for the mass, molar mass. We are working with N2, 2 times 14, 28. And therefore, the mass, hopefully 6,72 grams of N2. Right, now for practice, there's one more at the bottom. Do number 2 there at the bottom. Right, let's look at this one. Number 2. It was a reaction of calcium oxide and HCl, and they gave you the balanced equation. And then they told you of the calcium oxide, we've got a mass of 19,5 grams. I actually work with 19,6, so I'll just have to correct that a little bit. And there they give you concentration 2 moles per cube decimeter, volume cube decimeters, that would be 0.2. So the first thing was just to get moles. So at least there's easy marks there. So it will be N is mass divided by molar mass, 19, I use 19,6, so just check my maths there, 5, 6, 0,35. Did you also get 0,35? Okay. Moles of calcium oxide, and that is what is available. And then I look at the HCl and I see C equals N over V, 2 N over 0,2. The moles, 0,4 moles of HCl is available. That's what I have. And now I have to decide which one is in excess. So let's choose one to ignore. We start by say, let's ignore. Which one do you want to know? Let's ignore this one, right? And say if all of the calcium oxide reacts, how much HCl will be needed? So for all calcium oxide, we know calcium oxide to HCl is in the ratio of 1 to 2. So if all of these react 0.35, then I need 0.7 moles of HCl will be required. And now I go and see, what do I have available? I have 0.4 and I actually need 0.7. So what does that tell me? I need more than what is available, right? So it will be used up before all the calcium oxide. So HCl is the amount that is required is more than the amount that is available. And therefore the HCl is my limiting agent. Limiting agent, right. So immediately, if HCl is my limiting agent, I will just forget about calcium oxide for the rest of the question. Okay, so that was the first part. And then in number B, they ask you, calculate, or still in the part of number A, now calculate how much of the calcium oxide can form. Now that was the calcium chloride was on that side. I have to move, and now it's an easy one to get that mass, right? So the ratio was calcium oxide to HCl. No, sorry, the ratio was HCl, right. You're working with the limiting agent and going to calcium chloride. They're in the ratio 2 to 1. And I had 0.4 moles reacting, and therefore 0.2 moles of calcium chloride is being formed. And now they don't want that as moles, they want that as mass. Molar mass, 111. So you got a mass of 22.20 grams of the calcium chloride. that's being formed. Everyone happy? Right, and then we get to the last part, which is sometimes the more difficult one, right? The number C, where they calculate how much of the mole reactant in excess will remain. Now, sometimes you can use your previous one. Once again, I can't. I have to do it the other way around. So for all the HCl, they're in the ratio 1 to 2. If all of the HCl reacts, how many of the calcium oxide will be used? 0.2 moles of calcium oxide will be used. And then I can say, okay, so how much calcium oxide remain? I started off with 0.35 and I used up 0.2, giving me 0.15 moles. And they just wanted in mole, so I don't have to put that into, let's see if I make it a little bit smaller. Can you still see that at the back? Right. So this is the grade 11, a little bit more difficult things, right? Everyone happy? Okay, now on the next page, yes. Okay, I'll give you 2 seconds, but then we're moving on. If there's some of you who need to come back and write down something, you can come back and break as well. I just want to move on because our time is flying, hey? Right. Now the next one, we're not going to do the whole question. I'm just going to do the discussion because we still have to move on to 2 equations together and also to purity. So just quickly look at this one. They say during a titration, and they're working with sulfuric acid and they're working with sodium hydroxide. Quickly write down the neutralization of sulfuric and sodium hydroxide. Right. Get the products, get the balance. Right, so the important thing, if you can't write the equation, you can't balance the equation, and then you can't do the mole calculations on that. There have to be a 2 in front of your sodium hydroxide, otherwise your mole calculations will be wrong. Now, they expect you to be able to write this. So you won't get away with saying, I do the moles, but I don't think I'm going to learn the equations. You have to learn how to write the equations, right? Okay, so let's look at this one. They say during a titration, 25 cube centimeters of that sulfuric acid. So for the sulfuric acid, they gave me volume 0,025. I'm just going to put it in cube decimeters, right? And the concentration of 0.1 moles per cube decimeter. They're giving me H2SO4, right? And it is added in an Erlenmeyer flask and treated with a sodium hydroxide solution. Right, so for the sodium hydroxide, they give me concentration 0.1 moles per cube decimeter. And now they say, calculate the pH of the solution. Now, stop the bus. If this one was going to end point, if I did a titration and I let it go to the end point, what should the end point be? Strong acid, strong base. The end point should have been pH 7. Is that right? But now they tell us, calculate the pH after the addition of a volume of 30 cube centimeters, 0,03 cube decimeters. And then they give us a very important thing. They tell us the end point is not yet reached. Okay, so what now? Now you can't take it for granted that they're in the ratio 1 to 2. Now, one of them will be the limiting agent and one of them will be in excess at that moment. Is that right? So what you're going to do is you're going to calculate the moles. Now, we don't have a lot of time. So for this one, the moles end up as 2,5 times 10 to the minus 3 moles of H2SO4. You know how to do that. Sorry? Is it too small? Better. Lot better. Right, so we're not going to do it just for a quick discussion. So you can work out the moles of this one, and you can work out the moles of that one. You can do that, that's easy. 3 times 10 to the minus 3 moles of NaOH. Right. But now one of them is in excess. So how am I going to determine which one is in excess? I'm going to say, okay, this is what is available. Let all the H2SO4 react. Right? So for all the H2SO4, H2SO4 to NaOH is in the ratio 1 to 2. Right. So if I have 2,5 times 10 to the minus 3 of this reacting, how much sodium hydroxide will it react with? 5 times 10 to the minus 3 moles of sodium hydroxide. And then the question is, do I have that much? I have 3 times 10 to the 5. Do I have enough? No. So who's the limiting agent? NaOH is my limiting agent. Okay, so all of the sodium hydroxide is going to react. There's some of the sulfuric acid left over. And now there's the question, how much H2SO4 is left over? Now, can I use my previous decision step? I started out with 2.5. Do I know how much reacted? No, so I have to go do the other way around as well. H2SO4 to NaOH, they're in the ratio 1 to 2. And now I know if 3 times 10 to the minus 3 of this is going to react, how much H2SO4 is going to be used? Half of that, 1.5 times 10 to the minus 3 moles of H2SO4 will be used. So what is left over? We started off with 2.5 times 10 to the minus 3, and we're now using 1.5 times 10 to the minus 3. So we're going to end up with 1 times 10 to the minus 3 moles of H2SO4. Right, so think about this. You put in a lot of H2SO4 and you put in a lot of NaOH. And whatever can react will react and produce a pH of what? Strong, strong? pH 7. So the guys that reacted, the molecules that reacted, you can forget about them because they don't affect the pH, right? The pH will be determined by what is left over. And we now know there's sulfuric acid left over. So let's just quickly say, what is the concentration of this sulfuric acid that is left over? What is left over concentration? Moles per volume. We now know there's 1 times 10 to the minus 3 is left over. What is the total volume now? Now, if you go back, you will see we used a volume of 0.025 and a volume of 0.03. They're all now in that flask. So what is the total volume? 0.055. Right. So it is the 0.025 plus the 0.03. All in the same container. And now you get the concentration is 0.018 moles per cube decimeter. And that is the H2SO4 concentration. Right, my H2SO4 concentration. And now we're back at yesterday. Yesterday I told you I've got a concentration of H2SO4 of this, calculate the pH. Right. What do I do? From acid, I have to go to H3O+. What do I know about sulfuric acid? Strong, and it is diprotic. Right. So from H2SO4 to H3O+, I should actually write the equation, but we're in a little bit of a hurry, is 1 to 2. Right. So what will be the concentration of the H3O+? It should be 2 times 0.018, which is 0.036, 6 moles per cube decimeter. Okay, and then pH is easy, right? So for pH, you'll just put it into negative log of that H3O plus concentration. Negative log 0.036 to give a pH of 1.44. Yes? Okay, I actually had to write down H2SO4 is a strong acid, right? And therefore it will ionize completely, right? And then you say, how does it ionize? H2SO4 plus 2 H2O because it's diprotic, right? So it gives SO4 2 minus and 2 H3O pluses. So they're in the ratio 1 to 2, right? Now, usually there's not enough marks for them in the exam to usually give for the equation, but it's nice if you have time, write the equation to show where you get the 1 to 2. All right. So when do I do this? When's there a limiting agent with a titration? If you're not at end point, right? If you are at the end point, then they are in the correct ratio. But if you add more than enough, then something will be in excess. If you haven't reached endpoint, something will be in excess.